Alrighty, over here we have our tangent graph. Over here we have our cotangent graph. So, tangent graph, just so you know, when you look at tangent, what tangent looks like here is tangent starts here and goes up, has an asymptote, and then goes to right there. That is one cycle of tangent. And for one cycle of tangent, you started at the midline and you end at the midline. Halfway through is an asymptote. Halfway between both of these is your A value. I went up 1. Halfway between these, you go down your A value. 1. All those are kind of important for tangent. Again, tangent starts at your midline, ends at your midline. Halfway through is an asymptote, an undefined value for tangent. Halfway between, you go up 1, or your A value. Halfway between, you go down. And that is how you graph a tangent. For cotangent over here, it looks kind of similar, but uniquely different. For cotangent, what you do, it's a little bit harder, but you have to first recognize for cotangent that there are asymptotes on each side. There's an asymptote over here and an asymptote on this side. And cotangent goes down like that. Cotangent always hits the midline smack in between the two asymptotes. And halfway between these is your A value. And halfway between here is your A value again, just below. So what you need to be able to do is be able to see one period of each and spot when is it tangent, when is it cotangent. Now, some way to kind of help you kind of keep track of it, let's do just a quick, small sketch. A tangent. What does a tangent look like? It has an asymptote down the middle with an up and a down on each side, unless you flip it. Cotangent has an asymptote on each side and is dropping like that. So tangent looks like this. Cotangent looks like that. You can kind of see it here when I highlighted it and marked the special spots. So for tangent, the front number is your A. This number next to the X is your B, and that's your K. Now the A is not your amplitude for tangent. Your A, I call it your vertical stretch. It's your vertical stretch. So it's not your amplitude, because amplitude means it's your highest or lowest value. And that is not your highest or lowest value. It doesn't, these keep going up and down forever. So you can't really call it an amplitude. But it acts just like an amplitude. You'll see why later. B, it's still related to your period. But as we talked about earlier, isn't your period pi? Isn't one cycle pi? So instead of doing 2 pi divided by b, your b is going to be pi divided by your period. Okay. To get b, you do pi divided by period. But if I want my period, what I do is I take pi and divide by my b value. So if I want b, I take pi, divide by the period of the graph. If I want my period, I take pi divided by b. What makes this different than sinusoids are sinusoids have a 2 pi there. What you have to realize is a tangent cycles through twice as fast as a sinusoid. It has 2 cycles in 2 pi, not just 1. So it's a little different. So you have to keep track of that pi and stuff. You also have to realize it's not an amplitude, it's a vertical stretch. Now what's nice is k is still your midline. Yay, something stayed the same. And that's y equals k. So we still got our midline. So from this function, I want to find the midline, vertical stretch, and period. Well, the midline we said is k, or the number added or subtracted at the end. So my midline is going to be y equals 3. My vertical stretch is your a value, the number in front. So the number in front of here is a negative, which would that be a negative 1? So it is negative 1. Now, with amplitude, wouldn't that be a positive 1? Don't you take the absolute value? But with vertical stretch, I want the whole thing. I want the negative to show that you're actually dropping. You're going upside down and stretching. All right, the period, well, your period is pi divided by b. Isn't your b for this problem 1/4? Your b is 1/4. So I'm going to go period is, again, pi divided by b. So that's going to be pi divided by 1/4. Put a 1 down there. Which would be pi over 1 times the reciprocal, which is 4 pi. So the period is 4 pi because it's pi divided by the number connected to the theta, or the x sometimes. Alrighty, we're going to find the midline of this one, and the midline is always the last number. So that'd be a negative 1. So y equals negative 1. Alright, your vertical shift is the number in front, that's going to be a 5. And your period is the number next to the x. That's 2 pi, but it's not 2 pi. It's going to be pi divided by 2 pi. Which, be careful, there's like a 1 there. That's 1 pi divided by 2 pi. Those divide out, leaving you 1/2 as your period. Last one, your midline. Well, there's nothing added, so that would just be y is nothing. Your vertical stretch is the number in front, so it's a negative 3. Remember, on an amplitude, you don't put the negative. And your period, well, your period is related to this 1/2 right here. Don't forget there's like a 1 right there. So we're going to take pi and divide it by a 1/2. Put a 1 underneath that, might help. So that's pi times 2 over 1, which is 2 pi. So my period is 2 pi for that one right there.